So with this clip, we're going to talk about section 9.1, and 9.1 deals with systems of equation in with two variables, meaning that we're going to have an x and a y that we need to solve for. So the first method that we're going to discuss is how to solve this equation graphically using a calculator. The best way you want to start off is probably going to get both y's by itself. So you move the x over, you move the 2x over, and you want to try to get x by itself just in the slope intercept form, y equals mx plus b. Then you should already know how to proceed graphing each equation in your calculator and then finding the intercept like so. So I think we already discussed this. If you go to your calculator and hit math, so if we go to y equals, you put in both of the equations. So let me go ahead and do that real quick. So we have y, the first one when I solve for y, I'm going to put the x over and it's going to be x minus 5. So let me throw that one in there real quick. So x minus 5. Drop down to the second one and we're going to put negative 2x plus 1. Negative 2x plus 1. So you can kind of see what it looks like. You hit zoom 6, kind of see what both graphs looks like. So you should look like here. This is our answer that we're looking for. This will actually provide us with the x's. So if I go over x and then y, if you find out what this order pair is, that's going to be our answer for x and y. So remember what we talked about before. You hit second trace. And remember what are we trying to find? Where those two lines intersect. So we're going to hit 5 and then hit enter 3 times. And it jumps you right there to where they intersect at. So x is equal to 2, y is equal to negative 3. So x equals 2, y equals negative 3. And we can always, again, check your answer by just plugging in the x and the y to make sure it equals 5 and then 1, and both of them is true. So this is the first answer we gave. We sometimes in my MathLab Plus, well, we know in my MathLab Plus, you have exactly one common point, one solution. That means it meets here, and that's going to be our answer. Consistent and independent will be the choices you choose in my MathLab Plus. Sometimes you'll get parallel lines. So as you can see, they will never intersect. So this is why we call it no common points. This is why we call it no solution. We won't have a solution to this answer because you can see the green and the red line, they will never meet. So this is inconsistent and independent. A good way to tell if the answer is going to be no solutions is if you look at the way the slope is running. These slopes are exactly the same slope because they're running here. Remember, if it's parallel lines mean the slope are exactly the same, and they won't ever intersect. So that's how you. It's not a good giveaway to know the solution is going to be no solution. This one here, you can't see the green line, but if you have the green line and the red line in exactly both of the equations are exactly the same. So not only the slope has to be the same, the y-intercept has to be the same. So what do I mean by y-intercept? So this negative, if this was negative 5 and this is negative 5 and they both have the same slope, this is where we get them both being on the exact same line. So pretty much they're touching each other. They're like right on top of each other. So this answer is going to be infinite amount of solutions. Why do we say infinite amount of solutions? Because the answer is here, answer is here, is here. Remember, they're touching. Both of them, the green one and the red one, is running the exact same. So all the answers will be many solutions. Will be all the solutions. So that's why we call it consistent and dependent for this choice. The next method we're going to talk about is substitution. I think substitution is mostly only used when we're doing two variables. The next section we're going to get into three variables, and this is where we will be using elimination will probably be the best method. What substitution is, it doesn't matter what letter you solve for. We're just going to solve for a letter. So to stay consistent with my slides, I went ahead and solved for x, bring the y over by adding, and this is what x is equal to. X is equal to x plus 5. So substitution, think about the word substitution. Whenever I see an x, I'm going to plug in x plus 5 into the equation. So here I see an x. I take this x plus 5 and plug it into the equation, and I solve. 2 times y gives you 2y, 2 times 5 gives you 10, distribute. Then I finish off by solving for y equals -3. I take the -3, plug it back in for this y, and then I figure out what x is now. So in this case here, two negatives make this positive. Bring the 3 over by subtracting. 5 minus 3 gives us 2. So our answer is going to be 2 and -3. So this is by hand. This is the 2 and -3 using the calculator. If the direction says use the substitution method, this is the steps that you need to do to get to the answer. In my MathFast Plus, the directions will specifically say use the calculator or graphically, or it says use the substitution method. You will be required to know how to do substitution, elimination, and on a calculator for this chapter 9. So please make sure you understand how to do all parts. So here now we're going to talk about elimination method. So elimination method is exactly what the word means, eliminate. We're actually going to eliminate one of the y, the x or the y, does not matter, to solve for one variable first. And then once we solve for that variable, then we're going to go ahead and plug it back in for the other variable to solve for there. So looking at this problem here, what would probably be the easiest letter or variable to go ahead and eliminate? The x's or the y's? If you think about it, if we add both of these two equations together, a positive y plus a negative y, wouldn't you agree that both of these y cancel out? So it'll probably just go ahead and be easier just to go ahead and eliminate the y's in this case and just solve for the x. So when I add these two together, equations 1 and 2, this is going to be also important too. Make a note of this. When we're doing equations, especially when we get into the next section, now I will remind you in the next section, you will need to label every equation that we work with. Number 1, number 2, number 3, number 4. We get into even sometimes number 5 and 6 equations. A lot of equations, especially when we do elimination methods. So it's really good that you label them as you go. But back to this problem here, we eliminated the y's, and then you bring the 3 over by dividing, and we get x equals to 3. So now we need to figure out what y is. Since I know what x equals 3 is, which one of these equations should you suggest that we plug them into? If you answer it doesn't matter, you actually got that right, because it really doesn't matter where do you plug the 3 in. You can actually plug it in for this x or this x and solve for this y. I would probably suggest that you put it in for this one, because if you look at this x right here, because if you look at it, the problem is already easy to actually go ahead and solve. But like I said, this particular one, they actually plugged it into the first one. So like I said, it doesn't matter if you plug into the first one, the second one, it's not going to matter. So please make a note of that also too. When you're going to check, you're going to probably ask you which equation to plug it into. You plug it into whatever equation you feel best is the easiest one to actually plug it back in to solve for the other letter. So if I plug it in for 3, 2 times 3 is 6. Bring the 6 over by subtracting gives -4. Remember the way of checking, you can use the graphical way of checking, but I do need to see work shown when required. bring in both again, make sure you solve for y, put both equations in for y for 1 and 2, go to intersect, hit enter 3 times, and you should get the exact same answer of 3 and -4. So y is -4, and then the x is 3. So here's another one that you can work on first. It would be great if you want to go ahead and work on this and pause the video while you work on it, you try to get some kind of solution or some kind of work going. But this one here is a little tricky, because if you look here, if you add them together, the x's don't eliminate and the y's don't eliminate. So this is where we're going to have to manipulate one of the equations, or sometimes both the equations, in order for us to eliminate one of the x's. So because these don't eliminate and these to eliminate, I can multiply this equation by something to help to eliminate something down here. So let's do just the x's. The common, looks like the common LCM, common multiple for both of these is probably going to be 20. So if I multiply all the problems here by 5, this will give me 20, 15, and 55, and then multiply here by 4, both of these will match up. So I'll multiply equation 1 by 5 and got these answers. Multiply equation 2 by 4. Here I got these solutions. See, now they match up now? This is going to be the key for elimination. You need to figure out what do we need to multiply the top one by, the first equation, the second equation by, so one of the variables can eliminate. That's our goal for, because it makes things a lot easier if we can get rid of one of these letters. And then we have this one letter to solve for, and then come back and plug this answer into the problem to solve for the other letter. So here we see that the 20s, they cancel out. I add them both together, get 23. Add these two together, get 115. Bring the 23 over by dividing. Y is equal to 5. So once again, your question asks, where do I plug this 5 in? Should I plug it here or should I plug it here? So if you listened before and written this down, again, it does not matter. You choose whatever equation you want to plug it into. For this particular one, I chose the first one. So I'll plug the 5 in. Multiply these together, got 15. Bring the 15 over by subtracting, get -4, divide by this 4, x is equal to 1. So my answer for this one is y equals 5, x equals -1. So here are some more that you can choose to go ahead and work on. I'm going to go ahead and, like I said, pause the video anytime if you want to kind of work on it yourself. But if you look at this particular one here, I chose to wanted to try to eliminate maybe the x's together. So I will need to, in order for that to happen, I will actually need to multiply the first one by 2, this one by 2, and this one by 2. So as you can see here, that gives us 2x minus 6y equals 2. The 2's cancel out, but look at this right here. Look what happens to the y's this case. -6 and a positive when we add both of them together. And when you're always doing this elimination method, it's always best to add the equations. Always add. This goes away, leaving me with 0. Add these two together, I get 7. So when I get this kind of an answer, it's no solution. There's no possible way 0 can equal 7. So anytime you get all the letters go away and you have a number equal to a different number, the answer should be no solution. So if you actually solve for y for each one of these, graph it, notice that both of the lines are going in the exact same direction and they're all parallel to each other. That's why there's going to be no solution. Part B, this one here, I'm going to choose to, we can do the y's this time. Multiply everything by -2. So if I multiply this by -2, I get -4. This one by -2 and get -6. And this one by -2 and get -12. As you can see for this one here, both of the equations look exactly the same because if we add them together, those cancel out. Add these two together, they cancel out. And add these two together, they cancel out. So when everything cancels out and you're left with 0 equals 0, this is where you're going to have infinite many solutions. Remember what we talked about, that if they're exactly the same equation, both of the lines is going to be drawn on top of each other. So all the answers, this answer, every answer up here is going to be the same. That's why we say infinite many solutions. Same slope, same y-intercept, intersects everywhere. The lines are exactly the same. Now, word applications, it's always best to write down the information that you have. This is just familiarizing yourself with the equation. These two numbers are made up. So if I'm thinking about camera coin worth $2.50, how much is it if I bought 16 of them? Well, $2.50 gives you 16, 40. That would be $40. The nuts is worth $7.50. If I were to buy 4 pounds of it, it'll be $30 and it's 70 here. So this is just an example. These numbers are made up, so we don't have to worry about it. I'm just showing you how to get what are we doing as far as multiplying the pounds times the dollar amount. So let's set them up in the chart. Caramel corn, remember, costs $2.50. Nuts is $7.50. And a mixture of both of them will be $4.50. So this is the mixture of both of them. So for here, if I have it on my pounds, the X plus the Y equals 20 pounds. So this is where in the problem where we say if we get a mixture of 20 as far as the pounds, we add them two together, we get the 20. So for this equation here, this is where we take these two and multiply them together. So $2.50 times X gives us $2.56X. Then we have $7.50. $7.50 equals Y. Remember, each one of these represents the pounds. So going back to what we talked about before, 16 pounds, that was the X I made up, and this is the 4 pounds for the Y. If you add them both up, we get 20. So now what does the equation look like? For this one here, we have X plus Y equals 20. And then for this one here, we have here. So this represents the pounds. This represents the money as far as the cost. It'd be great if you can kind of keep those two separated. Whatever we're talking about for makes one equation, the mixture value makes the second equation. So now that I have my two equations, I can try to do the elimination method. Now for here, it would be better if you just, how do they jump from here? They multiply everything by 10. Why do they do that? Because instead of working with decimals, if you multiply by 10, move this decimal over 1, move this decimal over 1, and then move the decimal to 900. It'll be a lot easier to work with whole numbers instead of the decimals. So that's why the numbers changed to 25, 75, and 900. We just multiply everything here by 10. That is not a requirement. That's just if you just don't want to work with decimals, then you can just do that. So now we want to eliminate one of the letters, either X or Y. It does not matter. Again, I will repeat, which letter you decide to eliminate first. For this particular one, I'm going to go ahead and eliminate the X's first. So I'll multiply everything. In order to get rid of a positive 25, if I multiply by a negative 25 and add them, you see that they both cancel. So negative 25, negative 25, negative 25, multiply all those parts together, I get this, this, and this. Add them together to cancel, add these two together to get 50, add these to get 40, Y equals 8. So what does the 8 represent again? This is always going to tell me how many pounds of nuts will make up for the equation. For this one here, we can check. So we take it into here. If I say 8 is here, in order to get to 20, what do you think this has to be? 12 plus the 8 gives us 20. So that's the check we did right here. We got 8 that beat our answer. So we plugged it in here. Move this over by subtracting. X equals to 12. So here's another one. I understand word problems can be very difficult at times, but just again, read it carefully, write down the information that you have, and understand the word problem. So for a couple of terminology in here that you might not understand is tailwind. This is where the wind pushes the airplane as far as against the wind, going through the wind. So if you go into the wind, you kind of imagine that the plane is actually going to slow down. But if you're riding with the wind, then it's probably going to speed up or help the plane go faster. So just think about you walking into the wind, you slow down, but if the wind is pushing you on your back, it's going to make you run faster. So that's what is kind of going on with this the airplane problem. So wind speed, the first distance is 3,000. The rate, wind speed plus the plane is traveling. And this 5 here represents the hours. That's with the tailwind. So that's why we have the plus there. Remember, with the tailwind, I'm going to get help with the wind. So that's why I have a plus here. If I have a plane speed and I'm heading into the wind, that means whatever the plane speed is going to be subtracted by the wind speed, and it's going to take us a little bit longer to get to our destination. Same distance, 3,000, but this one takes 5 hours because the wind is helping me, and this one here takes 6 hours because the wind, I'm going against the wind. So these are going to represent our both equations. Oh, and the distance equals rate speed. That's actually how do you find the distance, actually using the distance formula. D times R times T. The rate meaning speed, and your time gives you the distance that you travel. So for this one here, we're going to multiply the rate times the rate and time together by distributing the 5 in, the 6 in. You can either do it that way. I think it's a little bit easier if you just take, because these two are being multiplied together, just divide it by the 5 and divide it by the 6 to reduce these numbers so you won't have such big numbers. So again, it does not matter which direction you go. It would be a lot easier if you just divide the two and just work from these equations here, my equation 1 and 2. So for this one here, it looks like the easiest letter to go ahead and eliminate is probably going to be the W's, because if we add them together, I have a positive W and it's a minus W, and that's going to go ahead and subtract the two W's together. So subtract the two W's here, and then add the two P's. Then this here, we're going to divide it here, $550, not dollars, 550 is going to be the speed of the plane. Now we need to figure out the wind. So we plug the 550 back into one of the equations, move this over, we get the wind speed of 50. So the speed of the plane is 550 miles per hour, and the speed of the wind is going to be 50 miles per hour. These are some good problems to practice with. I left you with a few odd ones to make sure you check your answers in the back of the book, especially when it says substitution and elimination. And I have not assigned it so far, but book work will be required in some of these because I want to make sure you know how to do elimination or substitution.